And now we have Pat Clark with ARS.
Okay, I think I got a little bit of time here. So I'm pinch hitting for Mike Pellant. He's actually the lead author on this. And we'll see how this goes. This is my first time as well. So we're talking about targeted grazing and fuel breaks. So what is a fuel break? It's a strategically located and surgically applied method of, that's quick, of laying fuel breaks on the ground using grazing. The research program I'm talking about was developed by Targeted Grazing Team. It involves multiple organizations and cooperative ranchers in partnership. It's a very large experiment, multi-regional in scope, 3 project areas in the Northern Great Basin, and then we're looking for other project areas in other western states. The intent is to make this research project commensurate with the scope of the cheatgrass wildfire problem. We got some money from the BLM to do some monitoring of how targeted grazing works, and so we decided to use the AIM protocols. But AIM is only so good. You have to have a good experimental design to really make this work and become a research project. So each one of our 3 sites that are currently in place are actually true replicates within a larger experimental design. And then within each site, we actually have 3 fuel breaks going on. If we zoom in even further on, say, a fuel break, we can see that at each fuel break, we're actually pairing up treatment control inside and outside the fuel break, and those are distributed across the fuel break. And then if we zoom in even farther, we see that those paired treatment control sites were based originally pre-treatment on similar variation, vegetation, terrain, and soils. And finally, if we zoom in as far as we can go, we can see an AIM transect you all might be recognized, where we have transect clusters, where we can do LPI and species inventory and those kinds of things. So LPI, what we're using there on those transect clusters is looking at AIM-core-ridden carriers of cover, basal, foliar, litter, and bare ground as responses to targeted grazing. We're also looking at vegetation composition plots. We're assessing species richness and abundance as another measure of ecological response or environmental response to targeted grazing. And we're also looking at gap and continuity, gap being how the distance between the bases of plants or the canopy of plants, to look at things like soil erosion or potential for soil erosion, and the connectivity of the fuels we're actually trying to manage. Another core indicator that we're looking at is heights or fuel heights. I mean, that's basically the measure that we're trying to affect by doing the grazing. We're also looking at vegetation heights to look at the structural response of the ecosystems from grazing. And other indicators that we're looking at are using paired plots to look at the variability in production year to year, as well as inside and outside the exposures over time, or the fuel breaks over time, and looking at utilization and things. Preliminary findings indicate that so far we are getting significant reductions in fuel height, but we're not yet meeting our targets that we set of a 3-inch stubble height, and we're not really impacting continuity yet. In terms of ecosystem response, there's really no treatment control differences yet, even though we've been on the ground a couple, 3 years on some of these sites. So that's good news, bad news. And then the newest sites in Oregon and Beatty's Butte area, the 2019 data that we've collected so far indicates that treatment and control are well paired, has been the same as in the other sites, and so they're ready to be grazed now. And I think one of the take-homes that we're going to get to is that flexibility is required Intensive spring grazing is a challenge, particularly when you're dealing with phenological timing of cheatgrass and the changes in palatability associated with cheatgrass. So take homes. AIM requires a good experimental design. AIM is not science without one. And adaptive targeted grazing, AIM is adaptive for targeted grazing monitoring. And finally, flexibility is required. Thank you. Definitely, we're looking for more sites, so contact us. We'd be happy to bring you on board and extend this thing out in the scope that we planned. And with that, I'm done.
How long do they spend in the fuel breaks?
Well, it's really driven either by the phenology of the weather or the number of cows we can put on the fuel breaks. But we're shooting at a 3-inch stubble height or a weight measure on utilization is what our targets are. So we're impacting that loading. And so far, it's actually been the flexibility that's been the limiting factor. We just can't keep cows either long enough or they have to move off because cheatgrass has changed in phenology. Any other questions? Right up front here.
How do you deal with the water requirements for the cattle in targeted grazing in this format if water isn't readily available there?
In most cases, we're hauling water to those sites. It's one of the attractors to hold the cattle on site. So it's a water haul deal, usually a dirt road, and at springtime, usually this country's still pretty dry in terms of plies and things. So having water points on the site works pretty well. So, thank you.